Hello, all my students. So it's been a while since we've had a little chat. We've been busy doing projects, tests, and now we're going to start Unit 3. And Unit 3 has to do with t-tests. And as we talked about as we were collecting data for this unit, we talked about the fact that a t-test is when we want to know the difference between two things. And we're going to start with an independent t-test. An independent t-test is one that you have two different groups that are not related. We have no reason to believe that they're correlated in any way. And we want to know, is there a difference? So with an independent t-test, we have two groups and one variable that we measure. So let's use the example we just did with our eyeballs last week, right? So we started out this unit with our eyeballs and we decided, let's just look at something and see if we have difference. So we collected data with two different paper airplanes. Well, three, but we're only going to use two, okay? So today we're only going to use two. We'll use the other one eventually. So we had two different paper airplanes. We had the Dart, which is the standard paper airplane, and it goes the farthest. It's the simplest airplane to make, and I've never found one that goes farther. So it is the Dart against whatever else we measured. And for today, we're going to use the Sprinter. The Sprinter was that little airplane we made, that half of you made. The other half made a modified V-wing. The Sprinter was that cute little airplane. It looked like it would fly. It had all the right principles of weight in the front, sheet design, narrow at the front, but its wingspan would not support its weight. So it was kind of a dud of an airplane, and it didn't fly very far. So we have the Dart, and I took the data without the extra weight, without the paper clip on it for now. And we have the Sprinter. And we want to know, is there a significant difference between the Dart and the Sprinter? So in order to do that, oops, my pen is running out of ink. I have the Dart and I have the Sprinter. And I have a number of variables that I need to collect. I want to know if the means are different, but also is the variance difference. So I need the mean for both of these. Let's do it one at a time here. The mean for group 1, I need the mean for group 2, okay? And we can name them 1 or 2, but the easier thing to do, I have found, is to give them a letter that is significant to our study. So we're going to call them DNS. Okay, when I get to the new formulas, I'll use 1 and 2 so that I make it clear, okay? So we need the means for both. Well, we've done that. That's old stuff. That's just the average, right? And then we've done the standard deviation of the Dart. We'll just call it SYD. How that? We'll call it SD. Standard deviation of the Dart and the standard deviation of the Sprinter. Remember, the standard deviation, average distance to the mean, right? Now, this brings up a really interesting concept. In order to have a true independent t-test, there are some assumptions we need to get over. Okay, the first one is that the data is normally distributed. Let's start with normal distribution. So the first assumption, okay, number 1, normal distribution. And sometimes we know this because we graph it, okay? And in AP, you'll need to graph it in order to figure out if it's a normal distribution. If the n is less than 30, if the n is greater than 30, we get normal distribution on the central limit theorem, right? So, you know, we're going to go one way or the other. Normal distribution. Second thing is something called homogeneity of variance. Okay? Homo meaning same, geneity meaning variance. Homogeneity of variance. Is the variance the same between the sprinter and the dart, in our case? Okay. The third assumption is that they are randomly selected. Let me give you a good example of random selection. I wouldn't want to just take all the airplanes that flew the farthest and count them and leave out the others. Okay. On the other hand, I wouldn't want to do all the low ones and leave out the high ones. In our case, we're doing all of them, but in most cases, you're going to have a population, a very big population, like everybody at school. Okay. So we go, everybody at school, and I want to know if there's a difference between something. I can't select who I want to select. I have to do it randomly, because if I just select certain things, I've already predetermined the answer to this question. So we want to make sure there's random selection. Now, we need the number in each group, and because these groups are different, right, I need the number in the dart and the number in the sprinter. Okay? They aren't the same. Every single person in my stats class, all 70 of you, okay, collected dart data. But only some of you did the sprinter because others of you did the viewing. Depending on class, group, you know, we're in that weird, and I'm filming this while we're in quarantine, so it's kind of like you're not at school, so I have kind of weird numbers going on right now. All right? And I get different groups, and then I say, okay, we're building the sprinter, but it might be period 6's group 2 and period 7's group 3. Truly random. Okay, I'm an old lady. I can't remember what I said or what I was doing. So whatever I was doing at that time, that's the one we did. Okay, so I notice the sun's coming in and kind of making this hard to read. So from there, I'm going to erase this side just so I can use this board because it's not in the sun. The sun makes it hard, doesn't it? Oh, but we love having the sunshine. And because we're here in Mexico, guys, it's 74 degrees and it's March 16th. That's not a bad thing, okay? Very good thing. So, the next thing I need to collect is something called the standard error of measurement. And that's DART. And the standard error of measurement sprinter. So the SEM stands for the standard error of measurement. And it's capital S, capital E, little m, okay? And then I just put a sub D next to it so we would know it was the dart or the sprinter, okay? The standard error of measurement mathematically is equal to the standard deviation of any group, we'll call it X, standard deviation of X, divided by the square root of n. Some books use big N. I prefer little n because the way I've been teaching you is that big N is everything and little n is the number in that group. And because these can have different sample sizes, I want to use little n, okay? Because I think it's better. It's just correct, okay? So we're going to go with the standard error of measurement. You calculate one for each variable. Okay, and the reason is we need the standard error of measurement for each variable, the sprinter and the dart. I need the standard error of measurement for both to figure out what the difference is between them. So that's my next variable I need. It's called the standard error of difference, SED. So standard error of difference. I'm going to run out of room here, okay? Standard error of difference formula is the square root of the standard error of measurement 1 squared plus the standard error of measurement 2 squared. okay? Order matters here. You take this number and you square it and you put it here. You take this number and square it and put it here. And then you add these two things together and then take the square root of it. Perfect? Perfect. Now, the last number we need is t, and that's where we began with t-tests, right? If we're going to do a t-test, we need to find t. T's looked up on a chart when you're looking for critical t, but when you're calculating t, okay, it's done as the mean of group 1, we already have it, it's over here, the mean of group 1 minus the mean of group 2, we already have it, it's over here, and we're going to divide it by the standard error of difference. Now you can't have two standard error of differences because the standard error of difference says what's the difference between these two things. Okay, so your standard error of difference goes here, as does your t-value, meaning I have two Sprinter Dart columns, but when I start talking about the difference between them, I only have one column because I'm talking about two variables and I want to find out what the difference is between them. Okay? Perfect? Okay, so let's do it with some real numbers. I'll just turn these suckers over, but you didn't know I could do that. Okay? Oh, look! We still have stuff from, oh my gosh, that's a long way. That's very old. Okay. Should turn these things more often, right? Okay. So let's take some real data, because I can. And did I bring my computer back here? I certainly did. Okay. So I have your real data. So let's do the mean of the Sprinter. So this will be the Sprinter column. And this, no, let's do that. Let's be smart, Heidi. Be smart. Let's do, this is the Dart and this is the Sprinter. Okay? So our mean of our D and our mean of our S. And we need the standard deviation of D. And I need the standard deviation of S. And then I need the N of both groups because they're not the same. We talked about that already. And then we're going to need the standard error of measurement of the Dart and the standard error of measurement of the Sprinter. I'm going to need the standard error difference between the two, okay? And I'm going to need t. And that will tell me what the t-value is. And then I take the t-value after I get it, and I go and look it up in a chart. The chart will tell me if it's significantly different or not. And I'm just going to attach that into a tab inside your Unified Classroom page, okay? So let's work with some real data here. And let's start with the Dart. So with the Dart, I have a mean of 4.27 meters. And I have a standard deviation of 1.68. And so far in my data, I have 32. I still have one class that hasn't had their numbers put in, and some of you were absent because you blew me off on Friday, okay? So there we go. Over here with the Sprinter, I have a mean of 2.08 meters. Oh, this has a unit. Okay, my standard deviation is 0.7, and my N is 13. Okay. All right. So to get the standard error of measurement, okay, for the Dart, and the standard error of measurement for the Sprinter, I take the standard deviation, right? 1.68, and I divide it by the square root of 32. So that my standard error of measurement for the Sprinter is going to be 0.7 divided by the square root of 13. This one equals 0.18. Did my math ahead of time on this one. Okay, 0.18. All right. And this equals 0.30. Okay, so let's trade my computer for that handy 1985 Texas Instruments 330 XA. Didn't have a 100 on it. Okay, so over here I write the standard error of measurement for the dart is equal to 0.3. The standard error of measurement for the sprinter is 0.18. Oops, make a real ID. Okay, so my standard error of difference, remember, is equal to the square root of 0.3 squared plus 0.18 squared. You see where I got those numbers? Those are these numbers, 0.3 squared, 0.18 squared. I'm going to add those together, so we'll take 0.3 and I'm going to square it, plus 0.18 and I'm going to square it, and it equals 0.1224, but I got to take the square root of that. So the standard error of difference is 0.35. I'm rounding here, guys. Okay, never take it more than 2 decimal places. We can't measure that well anyway. All right, so far so good? Perfecto. Okay, so T is the mean of group 1, okay, 4.27 minus 2.08, and I'm going to divide it by the standard error of difference, 0.35. So if I take 4.27 minus 2.08, I get 2.19, and I divide it by 0.35, I get 6.26. Then I need to find out what T critical is. And then I can see if it's significant or not. That's it. That's it. That's all we're going to do today. One dependent t-test. Okay, and we're going to find T, and in our groups this week, we'll look at the T critical chart, and you'll tell me if it's critical or not. Next time, dependent t-tests. A little harder. All right, talk to you later. Bye.